Let's illustrate all this in an example. Let L denote a language that contains all the words in 0, 1 star that have an even number of ones in it. So how can we model this with a Turing machine? Firstly, we have to think about our transition function. So the transition function delta is modeled here by a transition function table. On the left, you observe the states that we're currently in, and at the top, you observe what symbol stands in the tape square. And let's say if we're at Q0, and then we have 0 standing in the tape square, then we stay at Q0, and then we overwrite the 0 by B, and then we move 1 to the right. So this is how the transition function works. So how many states do we have to have such that we can have a Turing machine that decides this language? So first of all, let's try to define every element of the Turing machine. Firstly, let's define our input alphabet. Our input alphabet would be exactly 0 and 1. And why? Because the Turing machine would take the words W as an input. So it would have to match that. And then our tape alphabet would contain 0, 1 and the blank symbol. The blank symbol is just the same as before. Now, how many states do we need? Here we only need 3 states as described here. Q0, Q1, and Q2. Q0 would denote that we have even number of ones so far, and Q1 would denote that we have an odd number of ones so far. And Q0 is the halting state. So Q bar is equal to Q2. And Q0 is the same as the starting state. So we start from Q0, and why? If we have nothing, if we did not observe anything yet, then this means that we have observed an even number of ones. Why? Because 0 is even. So if the current symbol that we're reading is 0, we don't have to change anything. If we are at Q0 and if we're reading 0 from the tape square, then we stay at the state Q0 because we did not observe any additional ones yet. We overwrite the current tape square by B, which is a blank symbol, and we move 1 to the right. Similarly, if we are at state Q1 and then we observe 0 in our tape square, then we don't have to change our state. We stay at Q1, we overwrite the tape square by B, and we move 1 to the right. The interesting part is when we observe 1. So if we are at state Q0, indicating that we had even number of ones so far, then we observe another one. This would mean that now we have an odd number of ones in the word. So we would overwrite the current tape square by B. We would change our state to Q1, and we would move 1 to the right. Similarly, if we're currently at state Q1, which means that we have an odd number of ones so far, and then we observe another one, this would mean that we need to move to state Q0, overwrite the current tape square by the blank symbol, and move 1 to the right. From the transition function, it should be clear that we are computing the word step by step from the left to the right. So at one point, we arrive at a blank symbol. And as we arrive to that blank symbol, 2 things can happen. If we were at Q0, this would mean that we observed an even number of ones, Then we overwrite that blank symbol with 1. We don't move anywhere and we move to state Q2. If we were at state Q1, which would mean that we had all number of 1s so far, then we overwrite our current tape square by 0. We change our state to Q2 and we stay in that tape square. As you can observe, we don't change anything if we're at Q2. So Q2 is the halting state. And since this is a decision problem, we indicate the accepting and rejecting states by 1 and 0. So if we are currently at the halting state and in the tape square it says 1, then this would mean that we are accepting. If there is a 0 in the tape square, then this would mean that we're rejecting. So let's see all this in action. Let's say that our input x is 10111. In the Turing machine tape, this would have blanks on the left-hand side 10111 and blanks on the right-hand side. So we start at initial state Q0. And you're pointing at the 1. So this would mean that we're currently at state Q0 and we observed a 1. Our transition function says overwrite the 1 with the blank symbol, change to state Q1 and move 1 to the right. We overwrite it by blank symbol. We move 1 to the right and change our state to Q1. Now, we observe a 0. Our transition function says don't change the state, overwrite by B, and move 1 to the right. So that's what we do. Now we observe a 1. According to our transition function, we change our state to Q0. We overwrite our current tape square by blank symbol and we move 1 to the right. Now we're at state Q0, we observe a 1, we change to state Q1 and overwrite the current tape square by blank. Similarly, we are at state Q1, we overwrite our symbol by blank and we move to state Q0. Now we are at state Q0 and we observed a blank symbol. This would mean that we overwrite our current symbol by 1 and we move to the halting state, which makes us accept that word. And as you can see, the word itself contains an even number of 1s. And as you can see, our input word contains an even number of 1s. So we did well.